Hello, everyone. Welcome to class today. Kind of weird because you can hear me, but you can't see me. I hate the sound of my voice, so thank God I don't have to listen to this and you do. But anyways, today is chapter 6.1 and 6.2. So this is the introduction to trig. Like I said before, we're not going really deep into trig. This is not a trig course, but you are going to get a basic overview of it and just some simple things that you have to be able to do. So without further ado, let's dive into chapter 6, and we're going to start off with 6.1. In chapter 6.1, these four things are pretty much important and pretty much the things that are going to be on the test. I wanted to go over just kind of a definition of trigonometry, just so you could kind of get that, so you understand why we're doing this. In trig, you do have 6 trig functions, and we are going to go over what those are. You probably have already heard of them or seen them on the calculator. They are sine, cosine, tangent, and each of those has a reciprocal per se, and we have cosecant, we have secant, and we have cotangent. And we're going to look at more what those are. There's 2 ways to look at trig, triangles and a circle. So we're going to look at both methods so you can see that. Applications of trig, anything that happens over and over and over. So for example, sound, current, your heartbeat, anything that's cyclic in nature. So something that they say the tides are actually trig functions. So anything that happens over and over and over and over and over and over again is a trig function. And it's related to a circle because a circle can spin over and over and over and over again. It's also a technique for triangles that you can use. You can use it to find sides and angles of right triangles. So the application is triangles as well, and we are going to look at that. So anything that has a triangular relationship, you can use trig to do that. The next thing is, by having trig, it allows for actually negative angles. You never ever have negative angles in geometry, because what's negative 30 degrees? Like we don't know what that is. But however, on a circle, you can go forwards and you can go backwards. So you actually have doing a 360 is different than doing a negative 360. So you can turn one way or you can turn the other way. So it's totally different ways to turn. And that's actually called negative angles or negative direction, which you don't really have in geometry, but you have in trig. So we're going to kind of go through all that, and we'll talk about that. It's a lot like geometry, so a little bit applications of that. You're going to see the same measurement for the angles. You're going to see degrees. And you're also going to see a new measurement, which is radians. So all of that tied together, I know that sounds like a lot, but let's go ahead and break that down and just look at the things we need to do. So the first thing we're going to look at is actually drawing angles. Okay, so taking a look at drawing angles. First angle I want you to draw is 120. So if you take a look at an XY axis, you think about starting right there. And that's kind of where one of your lines is. Now, if I could pick that red line up and rotate it, if I would rotate it to here, that would be a 90-degree angle. Okay? So I'm not rotating it to there, though. I want to rotate it to 120. If I went the whole way here, it would be 180. So 120 is approximately, I'd say, right about there. So what we always do is draw a little arrow inside there to show that I actually went 120 degrees. And usually they'll write the 120 in there to show that they went there. Okay, so just to do a couple other ones here, just some of the basic ones. And then we're going to go ahead and do a negative one so you can see. So again, if you stay right there, that's technically 0 degrees. If you start here and you rotate up to there, that's actually 90 degrees. If you start here and you rotate the whole way to the other side, that's 180 degrees. And the last one, if you rotate the whole way down to there, that's actually 270 degrees. And there's actually one more I kind of want to write, and that's 360. So if you do a 360, you turn the whole way around. So starting at the beginning and going the whole way is a 360. So that is kind of those are the most popular ones that you're going to see. But okay, so let's look at a negative one. So we did 120. Let's do negative 200. So if I'm doing negative 200, I'm still starting here, but now I'm just twisting the other way. So instead of going up for positive, you are going down for negative. If I go to here, that's negative 90. If I go to here, that's negative 180. So negative 200 would somewhere be probably over there. So that big angle is negative 200. And of course, the piece that's left would be the part that would add up to 360. So if you go the whole way around, it does add up to 360. So trig allows you to have negative angles, and it's just going the other direction. So it's nothing too difficult. And it actually also allows you to do big angles. So you can actually do an angle such as 400 degrees. Because the beauty of circles, they keep going around and around and around and around. So you start here, and if you go the whole way around once, you go 360, and then you need to go another 40 degrees, so about there, and that actually is an angle of 400. And it's because we went the whole way around and then a little bit more. So you could actually go, around and around and around. So I've seen some things with these circles like crazy in the center. But just so you realize that you can draw these angles in actually the coordinate plane now. So rather than just on a piece of paper like you did in geometry. So it kind of actually like goes around the XY axis. Okay? All right, so with these angles comes ways to measure them. And we can measure them by converting from degrees to radians. Radians is going to be the new measure. You're probably used to degrees. The degrees has the little circle symbol. And radians is going to be the new one. There is going to be a pi in your answer. Okay? When you convert to radians, radians has no decimals. And like I said, there should be a pi in your answer. So let's look at how to do this. So first off, I'm going to give you 90 degrees. I'm going to give you 120 degrees. I'm going to give you 315 degrees. And I'm going to give you 45 degrees. And I am going to give you, let's do 360 degrees. Okay? So the idea is, how do I convert those to radians? And what is radians? Well, in trig, pi is equal to 180 degrees. And I think that's the best fun fact I could possibly give you. And it's going to come in handy. So when we convert from degrees to radians, what you want to do is multiply by pi over 180. All right, so that's the first thing we do. We multiply by pi over 180 times pi over 180 times pi over 180 times pi over 180, and I'm just going to do them all, times pi over 180. Okay, so when you do that, that's the first step. Then you must reduce your fraction. And do not divide and get a decimal on a calculator. We just have to reduce. So what fraction am I talking about? I'm talking about this fraction here. You now have 90 pi all over 180. So how do I reduce that? I can reduce, well, first off the zeros, and then 9/18 does reduce to pi, 1 pi over 2. Next, same difference. You have 120 pi over 180. And likewise, I can reduce this. I can cross out the zeros, and I can reduce 12/18. I can divide them both by 3, and I get 4 pi over 3. Divide them both by 6, actually, and get 4 pi over 3. Okay? The next one, you have 315 pi all over 180. And I think this one's a little bit more difficult just because of the 5. So what I would suggest is when you reduce these ones, just because they get a little bit bigger, I would divide by 5 first. So if I divide both of those numbers by 5, I end up with 63 over 36. And then those numbers actually reduce further. You can divide them both by 3, say. So you get 21 pi all over 12. And you can actually reduce it again by 3, so you end up with 7 pi over 4. And that's fully reduced because it's 7/4. So, I mean, you may be able to get there quicker, but I wanted to kind of show you the process to go through that to reduce a fraction in case it was a big number. And the last two here, 45 pi over 180. If you reduce 45 over 180, you end up with 1 pi over 4. And again, you don't have to write the 1. It's just pi over 4. Okay? And then lastly, 360 pi over 180. Well, if you take a look at 360 divided by 180 is 2. So that just is 2 pi. Now, it's really easy to check your answer because remember what I told you, pi is equal to 180. So if you actually go back through these and plug a 180 in the pi spot, you should get the answer. So right here, for example, pi, if I put a 180 in here and divide by 2, what do you get? Oh, you get 90. Okay, so that was the actual answer for the degrees. So, but there's 2 different versions of looking at it. When you take a full-year trig course, you start looking at these things and you think to yourself, you start memorizing them. So you know this is 90 degrees, you know this is 120, you know all of these are certain degrees. So that's converting to radian measure. Okay, be sure to leave pi in your answer. And that is that. So I do have those questions on the quiz. Please make sure you can convert that way. Now we are also going backwards. So you can convert from radians to degrees. So this one is where you have a pi and you want to go to the degrees. Personally, I think you're going to use this one more often. Okay. Just because degrees are just more familiar, so you like to see what it is in degrees. And this is actually easier. So the only thing you do here, so well, first off, let me write a couple down. So you have 3 pi over 2. I'm going to give you 5 pi over 3. I'm going to give you 2 pi over 3. And I'm going to give you pi over 6. What are these actually in degrees? Well, all you do here is let pi equal 180 degrees, period, and divide. It's extremely easy to go from radians to degrees. So what do I mean by that? I mean you are literally putting a 180 into the pi spot. So 5 times 180 divided by 3, 2 times 180 divided by 3, and 180 divided by 3. And all you have to do is do the math on the calculator. So what is 3 times 180 divided by 2? That is 270 degrees. What is 5 times 180 divided by 3? That is 300 degrees. What is 2 times 180 divided by 3? That is 120 degrees. And what is 180 divided by 3? Oops, that is 60 degrees. Okay, so kind of gives you an idea of what they are in degrees and what they are in radians. Like I said, I think this is the one you use more often, and it seems to be the easiest, like the easiest. So that is converting from radians to degrees and degrees to radians and angles. And that is the first thing that you will have to do using trig. So I will continue with the second video on 6.2, and thank you.